All right, today we're going to put on our detective hats. We've got a case on our hands, an application that's gone, well, kind of rogue. Something's just not right, and it's our job to dust for digital fingerprints and find out what's really going on. So picture this. You're using an app, one you use all the time, but today it's just acting weird. It feels off. And right there, that's our digital crime scene. It's that gut feeling that tells you an investigation is just getting started. Okay, first things first. Any good detective knows you start by securing the scene and looking for clues. We need to figure out what the very first signs of trouble are. What tipped us off that a digital crime might have been committed here? Well, the first clues, they're usually hiding in plain sight. Maybe you type something into a search box and the whole page just crashes. Or you get this bizarre error message full of code you don't understand. Or worse, you click a link that takes you somewhere you definitely did not want to go. These aren't just little bugs, you see. These are the fingerprints left at the scene. So you found the clues. You know something is wrong. But now what? How do you report it? How do you turn that gut feeling into a solid lead that your team can actually work with? Because just saying, hey, it's broken, isn't going to cut it. We need a system. And luckily for us, that system has a name. Every good detective needs a field guide, right? A way to identify and classify what they find. For us, cyber detectives, that handbook is OWASP. Just think of OWASP as the official glossary for cybercrime. It gives everyone, from the brand new developer to the seasoned security expert, the same language to speak. So when one detective radios in a code A01, everyone on the force knows exactly what kind of threat they're dealing with. No confusion. And this really shows you the difference it makes. I mean, without a common framework, we're all just guessing in the dark. It leads to confusion, wasted time, you name it. But with something like OWASP, we go from just guessing to actually classifying, and that brings clarity, which means we can communicate effectively and make decisions way faster. It basically professionalizes the whole investigation. All right, time to open up the case files. Using our new detective handbook, we're going to profile some of the most notorious criminals out there. These are the usual suspects that pop up in case after case. First up, injection. This one is a master manipulator. It works by tricking an application. It slips malicious code into places that are only expecting simple data, like a username or a search term. So the system thinks it's just looking up a name, but it's actually been given a secret command like, hey, give me your entire list of user passwords. Sneaky, right? Next on the list, we've got broken authentication. This one is the master of disguise. This vulnerability lets an attacker just waltz right through the front door, either by using a weak password or by stealing something called a session token, which is kind of like swiping someone's ID badge after they've already scanned in. And just like that, the attacker has the keys to the kingdom. And then there's this one, a crime of just pure negligence. Sensitive data exposure. You know how some people write their passwords on a sticky note and leave it on their monitor? Well, this is the digital version of that. It's when critical info like credit card numbers or passwords isn't properly protected and is just left out in the open for anyone to grab. And finally, let's look at broken access control. Imagine you have a key that's supposed to open the mailroom, but for some reason, that same key also opens the CEO's office. Yeah, that's a problem. This isn't about tricking the system like injection. This is about the system having faulty locks from the get-go. The rules about who can go where just aren't being enforced. Okay, so the theory is great and all, but let's see how this stuff plays out in a real case. It's time to put our skills to the test in a live investigation. And our prime suspect? It's a feature you probably use every single day, the humble search box. So how does this crime actually go down? Well, first, the attacker types something into the search box that isn't a normal search. It's actually carefully crafted code. The system, because it wasn't built to check its inputs, just takes it and processes it. And boom, those hidden commands execute and suddenly the attacker can steal data or even take over the whole server. The search box was just the unlocked window they climbed through. And here's the real key to the whole case. The weapon wasn't the search box. The real crime was the underlying pattern. The system just blindly trusted what a user gave it. Once a detective learns to recognize that pattern, you can spot similar weak spots anywhere, long before they turn into a full-blown disaster. Which brings us to the most important part of all this. See, the goal isn't just to memorize a list of categories from a handbook. The real skill is learning to think like a security detective. to build that instinct for spotting suspicious patterns no matter where you are. So here it is, your detective's checklist. When you're looking at any piece of an application, just ask these 3 core questions. Is it trusting user input way too much? Are the locks on all the doors actually working correctly? And are the crown jewels, the sensitive data, locked up tight? This mindset is what separates someone who just reviews code from a true security detective. So the patterns are out there, and now the handbook is in your hands. It's your turn to start the investigation. Time to start asking the tough questions.